So when your revenue is going over the network, which happens for digital enterprise, happens for service providers, how many people make most of their money with applications or services that they deliver that are not infrastructure? So like enterprise, okay, and how many people are service provider or digital or hosting, things like that, CDN? Then not knowing what's going on is not really an option. And in this talk, in a brief period of time, we'll talk a little bit about what data sources you have, what you can do with the data, especially when you combine it, how you can invite other groups in the company that don't traditionally use traffic analytics tools in and how they can get value, what some of the open problems are, and sort of why I think it's very interesting space evolving very fast and will actually be getting much better continually over the next few years. So first problem is, why does the traffic go where it does? I want to actually update this and show underlay and overlay, and we've got a whole bunch of complexity. A friend of mine, actually one of our customers, was talking about a trial they're doing on Google, and when he described to me how they do their networking and the VPCs appear with each other and talk to other applications, and the whole thing just made my head explode. And it's like, okay, very complex. And for a lot of the cases, you're basically just giving some rules and other things are doing it, and then it's a big debug problem. And without actual data, we're just sort of guessing. And as everyone knows, in networking, it's really a bunch of rules and algorithms convolved with vendor bugs. And so in our world, we really have to know what those rules are because we have to actually be able to go find those bugs. So who here has a Star Trek knock? Star Trek knock, like more than 20 displays? Okay. How many people have tools for pinging things and seeing if they're up or down? Configuration monitoring, configuration management, metrics like SNMP. How about receiving streaming telemetry metrics? Okay, yeah, I have other questions about that later. BGP monitoring, hijacking, health. NetFlow we talked about. I probably forgot a bunch of them, but there's a bunch of them. You guys, should we play? We were actually thinking of playing like, guess the tool and like quickly pop it up and see what it is. So this is the AT&T Death Star knock. And the question is, what do you actually do with this? I was up in Cambridge, walked past the Akamai knock and saw the things we built in 2004 to impress the government that there was impressive stuff going on, none of which is actually used by the people running the infrastructure. So at a very wide extreme, you've got SNMP, and then you're like, double click on that. Why is that? That's sort of flow. And on the other hand, one of the things I want to talk about is, what if you put all that together, right? So you have AS, you have customer ID, maybe you have application name, you have some of that metric stuff, maybe you have performance. How do you put all this together, and then what can you do with it? And I think it's a very interesting world, just as we often ask for features more than stability from the router vendors that we love to blame for writing crappy code. We often do the same thing, pushing ways of doing things into production without thinking about how we're actually going to monitor that they're doing what they should. How many people here are doing intent-based networking? Intent. Do you know what the intent of your network is? How many people have heard the term intent-based networking? Okay. And it can be confusing because sometimes when you look up these things and they sound like protocols, and they're actually just intent to market. So in some sense, intent-based networking is the intent of everybody to figure out how to go do the intent of what you're actually doing. If you're going to do all this together, if you take this data and you're trying to run ultimately the network, which is supporting things, how many people here use one of the big three cloud providers in their, for their core business? Amazon, Azure, Google, right? Even things which look like outages, which have nothing to do with the network, they're all network outages, right? The storage is a network connected thing. The compute is all connected by the network. Like 85% of those, are network related. So the network winds up being important to this, and so planning, how do you interconnect, sometimes even within internally, congestion, security, and that's something we really see converging. How many folks have what are tools owned by security groups that IT and operations and NetOps use? Anyone have that kind of interaction? How about the reverse? How many people have security folks, like for forensics or things like that, that use, okay? And how many people think DDoS is a security thing? Okay, and how many think it's like a IT and availability thing? Okay, well, you have both, right? To me, it's sort of like, you know, DDoS is it's strictly availability, like I shove your head in the toilet. And then I may come along and pick your pocket, which is easier because I've just denied you access to air. And so you're not focused on that. But from a budget perspective, often it lives in both places. And we've seen people say, that thing you just showed me, we can't use it because it's a network tool. And security people, you know, we think about antivirus and all that. In the enterprise, we actually see a lot of these things converging because even more than I thought would happen, say 4 or 5 years ago, a lot of what we call, you know, of like the digitally transforming companies, the guys that want to be modern, their security people are saying all this dynamically created stuff and not knowing whether it's a problem. And the IT people are being affected by security people playing whack-a-mole with stuff that's actually supposed to be. So we actually see a little bit of a convergence. And one of the key messages I want to get at is, if you take the right data and can fuse it together and wave your magic wand, this data can be useful for multiple people. So I actually asked about sales and finance. So the finance question is, how much does this customer cost me? The sales customer is, of my people that I send traffic to via peering, who of them should be my customer? And it comes back to the first. That would be profitable, right? So put all these things together and you can fund new tools. So if you can solve problems for other people that they need to have solved, it actually helps justify it. Now the problem is, just take this stuff, turn your beautiful binary into ASCII, stick it in JSON, stick it in Kafka, stick it into a data swamp, doesn't help, right? Just having the data doesn't help. You have to put it together and use it some useful way. But this is the ultimate goal, and this actually opens the key to budget. So the tenet that I've always had for a very long time is start with your actual traffic. When I showed up at Akamai, I was at Akamai for 10 years. We were calling ISPs based on the, anyone remember Boardwatch magazine? The Boardwatch ISP directory, that was where Keynote got launched. So they were calling down the list of like by subscriber count. And I was like, well, how do we build customers? Let's do BGP. Let's figure that out. Let's look at what we're actually doing. Not what might be, but what actually is. But the actual traffic, how many people in their traffic analysis system, when they look at flows, can see the customer, revenue, and applications used? Okay, for UCANT customers, we'll fix that. But taking the business metadata about what does this traffic mean to me, and putting it together is one of the key things that you can do to actually make it useful. And to actually make it useful, again, sticking it in a data swamp doesn't help. Having it be something that everyone can write programs to on a streaming bus alone doesn't help. You do have to fuse it, and you do need streaming in real time. We'll talk a little bit about that. So how do we do it? How many people have an open source system for starting looking at traffic? PM account, NFDump. Those you can usually get BGP in, but pretty hard to get other sources of data in unless you build your own ingest layer. How many people have actually built an ingest layer to aggregate business data like application and customer and revenue with Flow? We'll talk a little bit about that. And how many people have commercial software that runs on Windows machines? That would be SolarWinds. Okay, we have some people. And how many people use SaaS services, send their flow off to a SaaS service? Something like that. Okay, cool. So we have a mixed approach. And to do that requires a bunch of different things. So taking data from different sources. I have another talk that I do which expands regularly, which is what are the things that are not flow that are flow? Nginx logs projected over BGP with performance data from the TCP info struct that it can pull from the kernel. CDN logs, which often have performance data. These things are not in IPFix or V9, but if you have a system that can take them and they can express the richness of performance, combined with BGP, they become very interesting ways of looking at looking at traffic data. You can even do that from hosts, turn that in. nprobe does that. We have something called kprobe that will turn PCAP into flow, but with performance, which your routers and switches generally can't do. By the way, how many people have Cisco Catalyst switches, 9300s? Okay, so very interesting thing. Cisco doesn't, well, there's like many BUs at Cisco. So they have this thing called encrypted traffic analytics. Does anyone use encrypted traffic analytics? It's integrated with StealthWatch. One of the IPFix templates that ETA has is the timestamp, basically the time of the arrival time of the first 20 packets from which you can see performance. So it's actually interesting. They don't think of that as a performance or NPM thing, but actually there is a switch which runs not as big scale as the Nexus, from which it can actually in the hardware observe basically TCP latency, which is actually pretty cool. It's not much in the service provider world, it's more of an enterprise thing. But we look for that. Where can we get data from that has more than just so many bytes and packets went from here to there? And then in the enterprise, what are the sources of data that make that relevant? So then you have to be able to fuse it together, which I'll talk about in a slide, store it and make it really, accessible, which isn't even on this slide, do something with, Ron talked about AI, and I was not in that talk, but he'll send me the slides. Do learning of some sort, and then, interface, API, both inbound and outbound. So how much data are we talking about? Our largest cluster runs at about 2.5 million flows per second. And if you add that up times the retention, you're talking about trillions of data points, each of them 80 columns wide. So it can be a lot of data, but that's probably not as much data as you have in your networks. But you're still talking about a fair amount to keep it running and keep it running fast. So the part I really want to focus on here, instead of my passion about the network performance, is really the augment. Like, let's take this traffic and make it useful to people that are not the people that are going to say, oh, why is this link full? Let me move the traffic. Or do I have a DDoS? Or even if they do, they want to know what customer it is, not what IP address it is. So how many people own a flux capacitor? Okay, so you take your flux capacitor and you stick it into your Kafka and you send the output to your APIs, and then you're done. So from our world, I think of Patricia trees and routing tables. We have folks we work with who populate, and we have to find a good word other than metadata for that, because it doesn't really sound like the creepy Fort Meade metadata anymore. That sort of meaning has gone, but orchestration and automation, that's what they're talking about next door. So I got my conf hat because they have the everything must be Python, but I don't think whitespace should be syntax, so I don't like Python. So I think automation should be done with Pro. In the data fusion world, it's what can you get, and then how do you represent it? So you have a routing table, and you put that together with traffic data. That makes sense. Everyone does that. But what about your list of currently running applications? What about what IP addresses are in what rack or what zone? What about your NSX orchestration system, your Contrail orchestration system, your Kubernetes? All these things, why should someone have to look at your traffic and scrutinize by IP and then go look up somewhere else? To make the system really useful, do that. And how many people here actually prioritize when they have a list of 10 things to work on by how much revenue is impacted? I shouldn't say that. I'm the CEO of a company. We would never do that. All customers are important. But we actually work with people that do put revenue on the flow. So with all the traffic coming in, not only do they know the customer, but sort of by band, like, right, is this something, or not revenue, but like, will my CEO care, for whatever definition that is. And so we see people that put that into the operational regime, whether it's a security thing or a performance thing, and say, how does this work? All these things ultimately become tables in memory. And when traffic comes in, you're doing lookups and then augmenting it. So in our world, we use Cap and Proto. How many people here have code that uses protobufs somewhere? Okay, so some streaming telemetry. It's just like imagine a C struct that just keeps getting extended. So it comes in, we turn traffic into that, and then we do lookups and fill it in based on what users said. And you always have BGP and geography. So that's sort of the goal. How you do it, You can use streaming systems like Spark. I like Pipeline DB if you're not going to go build your own. Because we're old database people, we built our own. But there are a number of different systems that do this kind of streaming join. You still have to be able to do something useful with it afterwards, but that's sort of my #1 DIY focus if people are going to try to build their own, is think about all the different data sources and how you put it together. The kinds of companies we work with, basically, if they want SAP consulting, which is like come in and figure out our back-end systems and all that, then they're probably not ready for this kind of approach, whether it's DIY or vendor. But we found, again, really surprising number of people that you would think of as 50 to 200-year-old enterprise. They want APIs, they use APIs, they're familiar with it. You just give them access and then you can figure it out. So we think of it as done at ingest. Imagine you've got, whether it's DHCP or you've got NAT going on, you really have enough dynamic changes in the infrastructure that if you try to do this after the fact, you're just going to have stale data. Even IP geography, which is a horrible hack that's completely inaccurate, to the last 5%, it gets even worse if you try to look at last year's, right? Or certainly think of it as the routing table. So it's not just BGP and routing that you want to put on. You actually want to think about it in other ways. So, there are some basic things you can do, and this kind of graph, which is AS numbers and some devices and some countries, if you've ever done route maps or show IP BGP, or this makes complete sense to you. Makes complete sense to me. I even know, I don't know, we could play, that's, I guess that'd be a drinking game, like how many ASs do you know who they are by number? Note, I don't have any, newer ASs on here, so. This test network must not be talking to any of them. So, but if you put it into context, now it can make sense to people. So if Burrito Explosion is your customer, and you actually have a problem, then someone can say, oh, that's actually Burrito Explosion. Now, our view is all these fields, from the IP address, port, protocol, all that stuff, as well as the metadata, should all be together. So you could just as easily say, okay, well, show me the prefix either before or after, or the geography or the AS. It's just that some of these things aggregated up make much more sense. Similarly, application, whatever my internal application is, or data center, right? Which is, yeah, we know Microsoft has an AS, but it's got Office 365, it's got Azure. What is actually going on? Well, they'll actually tell you the prefixes of the different services, and you can use tagging. You can fuse this data together and try to take it out. And again, if you have the right controllers, you could actually be understanding what those tunnels are. What today, right now, is this thing, which is actually just a VLAN over my infrastructure. And then those become things just like IP addresses, just like ASs that you can look at. Different ways that's done, PM account. There is a little bit of a fusion layer, but mostly for BGP. Storage, actually, we should update this slide. It's more ELK is what we see people doing. But Elastic, how many people put Flow into Elastic? So Elastic has some limitations. It has no security model, no multi-tenancy model, is pretty big because it's taking beautiful binary, turning it into ASCII and indexing it with Java. And it doesn't understand prefixes or paths. But from a forensic perspective, and it's certainly going to be much faster than MySQL. Another issue with PM account is just sort of the front end. But that's one reason why people use Elastic is because it gives you a front end. We also see people doing nprobe, some of the same things. And then, Kafka right on the way in, which turns up even more Java. And again, Elastic for people doing their own is what we see mostly, on the other end, but still missing some network primitives. So you're still left up front somewhere before it gets into Elastic to fuse it together, because that's not something that Elastic has in its primitive. So that's really what we talk about, in terms of thinking and planning, and is how do you put all that together. So why doesn't everyone have their own system? Because it's actually a really hard problem. In the next room over, they're sort of talking about more programming and network, but to actually build Something that goes beyond one machine and is a big distributed service requires, specialty experience. So there are people like that. They often go to work for vendors, but we've seen them at various places. The other thing that we've seen is people build a system and then they leave, and then it can become hard to maintain. The good news is some of the things we're talking about, like streaming joins, the production big data systems are doing, whereas 4 or 5 years ago, you actually had to be writing infrastructure code. And for things that are sort of like taking the SAT, where it's like always the same questions and you can prepare it, then there's actually some pretty simple software nowadays to do sort of precise queries using probabilistic data structures that you can just hook up to Kafka and ask it questions. But that's still, providing that as a continuum between some pre-computed queries and then going all the way to storing all the details is still a little bit of work. So another part of my personal religion is where can you look for performance data? So how many people take streaming telemetry from routers or switches today? Again, remind me. There are some people. Okay. How many people pull out something beyond what they use in SNMP? Okay. If we had more time, we'd get into that. How many, do you pull out queue depth? Okay. So the thing that we're actually building a metric system, and when we take it, that's like the first thing, right, is on every flow. If I can't get actual performance, I just want to know how busy were the things running through it. If you're as fortunate as Russ this morning to just have no queuing, and QoS means quantity of service, that's a nice world to live in. I don't live in that world. I know very few people that live in that world, but I guess it's possible. What we look for is latency and retransmits, and there's some horrible, huge problems here, which is your latency, how do I compare that? It's like meds, right? You measure latency one way, latency here is measured another way. This is TCP, this is one-way latency, this is application latency. How do you put these things together? I still assert it's better to have it than not, and that's the one thing we keep bugging network vendors is, you got all this ASIC, you're telling us how powerful it is. Do that, or build us a flow sampling primitive, right? We can run a PCAP to flow generator that will watch latency on the CPU of an Arista, but not at 50 gigabits, right? Because there isn't that much CPU. So if you can get all the packets or none for a flow instead of just packet sampling, now you could deploy software, edge computed or VRFs, or just like otherwise. Stuck at the edge where you can actually do some of that performance latency and then put it in and answer the question, is it the network beyond just congestion, but actually, I'm sorry, I meant to say NFV, not VRF, different acronym. So when you put all that together, you can start looking at actual performance problems, not just, the link is full. By AS, by prefix, put together application data. It's another topic, but again, think of it as a fusion thing, right? If these are the columns that come in, you can project your traffic across network hop BGP, then you can start getting at how should I move my traffic to preserve the revenue. So once you do that, you can, it's important to be able to look at dimensions pretty flexibly, because some people care about customers, some people care about IP address. To be able to do bits per second, packets per second, unique IP addresses, unique ASs. These things are very interesting from a DDoS perspective, or from a BCP38 perspective, right? Like how many /8s am I seeing worth of, how many ports am I seeing over, 50 /8s worth of source traffic from? That would probably be relatively few on most networks, or ASs. And then to be able to do, again, another talk, which is how is this stuff changing and how does that impact me? And we can have the next CHI-NOG, maybe the AI debate of the noise in AI, right? Which is lots of things you can find that are anomalous. The question is how many of them would I be willing to be woken up about, and how many of them are explainable enough. So anomaly detection, I'll skip through this a little bit. DDoS, we have some people that again put the revenue of the customer there, so they know how to prioritize that. And in summary, lots of data by itself is not useful, but if you put it together in the right ways so it brings out the context of what is sitting behind the IP addresses, it can be useful across the company and actually get you money to fund the visibility that you want. It does take big data type approaches, both ingest, fusing it together, storing it, and running queries over it. The fusion is really the key thing, and I think it's actually a pretty interesting time because some of the APM vendors are trying to come down towards the network level. Network companies are trying to understand the server and APM, and of course, all the technology is changing underneath. So it's not quite as delta as being an ISP in the 90s, but it's actually, I think, even more fun than even, say, the CDN space today. No offense to our CDN friends in the audience. So we do actually have a couple minutes for questions.